Okay, ready to go. All right, so basically what we're doing is this. When we're solving trig equations, if the terminal side falls between two axes, so in other words, in one of the quadrants, there will either be two solutions or no solutions at all. If the terminal side falls on an axis, then it is possible there is only one solution. So basically what we're doing is the exact reverse of what we did yesterday. So when they say something like sine theta is equal to 1/2, you have to realize that that means theta is in the pi over 6 family. Alright? Make sense? So sine theta is 1/2 means we're in the pi over 6 family. Then you have to look at the sign. S-I-G-N. Are we talking positive or negative? Positive. And then you have to ask yourself, where is sine positive? In the first quadrant and the second quadrant. Make sense so far? So that means one of our solutions in the first quadrant is pi over 6. And then the second solution, which is in the second quadrant, would be 5 pi over 6. Because in the second quadrant, you're always one less than the denominator. Make sense? First quadrant is pi, second quadrant is one less, third quadrant is one more, fourth quadrant is one less than double. So you have to remember from the unit circle, all right, that sine is the y coordinate. All right, so you have to remember that's the 1/2, and then that's the root 3 over 2. So you have to go back to those values and know which one's which. Make sense? All right, cosine theta is a negative root 2 over 2. As soon as you see root 2 over 2 for sine or cosine, what family are we talking about? Pi over 4. Sine, cosine, root 2 over 2, pi over 4. Tangent, cotangent 1, pi over 4. We go from there. Now, cosine is negative here and here. Make sense? Okay, so up here we just talked about 1 less. What's 1 less than 4? 3. So we got 3 pi over 4. Down here is 1 more. 1 more than 3 pi over 4 is 5 pi over 4. Make sense? Cosecant is 2 root 3 over 3. You can either memorize that or realize cosecant is the inverse of what? Sine. And that would be 3 over 2 root 3. And then I have to what? Rationalize my denominator. So I multiply top and bottom by root 3 over root 3. Which would give me 3 root 3 over 2 times 3. Because the root 3 times the root 3 gives me 3. What do the 3's on the top and bottom do to each other? Cancel out. Giving me root 3 over 2. My original value is positive, so that means my sign is also positive. My sign is positive, like we said above. Excuse me, get a little emotional. First and second quadrant. So that means I would be at pi over 3 and 2 pi over 3. The alternative is memorizing that 2 root 3 over 3 is the inverse of 3 root 2. That may be something you want to do. That's up to you then. Again, you have plenty of time. All right, secant equals root 2. So what's the inverse of secant? Cosine. So that means cosine is equal to 1 over root 2. Which when I'm done rationalizing, I got root 2 over 2. Hot dang, because root 2 over 2 means what family am I talking about? Pi over 4. Can you feel the excitement? Pi over 4. You then have to remember that cosine is positive here and here. So one of my solutions is pi over 4, and the other one is 7 pi over 4. Because in the fourth quadrant, my numerator is 1 less than double the denominator. Cotangent is equal to -1. Cotangent is equal to -1. Hot darn, I'm still in the what family? Pi over 4. Whenever tangent or cotangent is 1 or -1, it's the pi over 4 family. Cotangent is negative here and there. Second quadrant is 1 less than the numerator, 3 pi over 4. Fourth quadrant is 1 less than double, 7 pi over 4. Good so far? Everybody smell what I'm stepping? Picking up what I'm putting down? Sorry, what I'm watching? Okay. Now, the tricky one is root 3 over 3. All right, the tricky one is root 3 over 3. When tangent is root 3 over 3. When's tangent root 3 over 3? So basically what you have to envision is two things. It's either in the pi over 3 or what? Pi over 6. It's got to be one of those. Because it can't be pi over 4 because tangent of pi over 4 is what? 1. So this is the only tricky one when it's root 3 over 3. So you have to either envision, think, or write down pi over 6. My y is the 1. My x is the root 3 over 2. Remember that. What do then the 2's do to each other? Cancel out. And then when I rationalize, so I multiply both top and bottom by root 3, I get root 3 over 3. In all honesty, I don't suggest memorizing for a lot of things, but the one thing I would tell you is when tangent is equal to root 3 over 3, that's the pi over 6 family. And when tangent is equal to just plain root 3, that's the pi over 3 family. I don't know any other easier way of doing it, unless you're going to go through that each and every time. So you got to make the choice. That's the only one that I would suggest if you're going to memorize one, memorize that. All right? So if I'm in the pi over 6 family, and I'm negative, that means once again I'm in the what? Second and fourth quadrants. All right? So I'm here and here. Here I'm 1 less. So I'm at 5 pi over 6. Here I'm 1 less of double. So I'm at 11 pi over 6. Alright. So root 3 over 3 may be the only ones you memorize. Root 3 over 3 is the pi over 6 family. Root 3 is the pi over 3 family. All right, examples on the axes from the notes we introduced yesterday. Cosine's equal to 1. Well, that means the x-coordinate is 1. So that means we're at 0, not 2 pi. We'll talk about that in a second. We're at 0, not 2 pi. Okay? Now, tangent does not exist. Tangent is y over x. Recall from yesterday, when it does not exist, we're focusing on the denominator. Because when it does not exist, the denominator is equal to 0. So you have to ask yourself, when is x equal to 0? And that, my friends, is in 2 places. Up top and down below. Up top is pi over 2. Down below is 3 pi over 2. And then sine theta is equal to 0. It's just the opposite. Instead of up top and down below, it's side to side. So that means here and there. So we're at 0 and pi. We're at 0 and pi. All good? So does everybody get the idea we're just working backwards? Okay, so it's the same material. All right, if we flip it over. Oh, man, look, that's just not nice. The first one they give us is what? Tangent is equal to what? Negative root 3 over 3. Now, here's what I want to focus on. Our solutions are between 0 and 2 pi. Our solutions are between 0 and 2 pi. All right? So again, I'm just going to go over here and translate the 5 pi over 6 and 11 pi over 6. All right? So that's the same one we did. Now I'm going to scroll all the way down to number 8. All right? I'm going to compare the two problems. So number 1, tangent was root 3 over 3. Number 8, tangent is equal to root 3. It's the opposite. It's the flip. So instead of the pi over 6 family, what family is that going to be? Pi over 3. So one of my solutions is pi over 3. The other one's in the third quadrant. In the third quadrant, we're talking about 4 pi over 3. So again, Thursday's quiz may have a lot of problems on it because a lot of these problems should be done in a short amount of time, if you know your unit circle. Cotangent's equal to 1. Anytime tangent cotangent's 1, what are we talking about? Talking about what? Pi over 4. Positive in the first and third. So 1 more than the denominator is 5 pi over 4. Good? Cosecant is equal to negative root 2. What's the inverse of cosecant? Sine. The inverse of root 2 is root 2 over 2, or the reciprocal. So that means sine is negative root 2 over 2. As soon as I see root 2 over 2, I'm thinking about what family? Pi over 4. But instead of positive, what do we got? Negative. So that means I'm in the third and fourth quadrant, so 1 more than the denominator would be 5 pi over 4. 1 less than double would be 7 pi over 4. All right, number 4, another nice one, believe it or not. Somebody do me a favor, put that in the calculator. 2 root 3 over 3 for me. Just put that puppy in. If you like puppies. If you don't like puppies, then don't. So 2 root 3 over 3. 1.15. Here you go. You ready? If something doesn't make sense to you, if you smell something fishy, take a look at that. Can sine ever be greater than 1? No. Therefore, ladies and gentlemen, that one does not exist, baby. Does not exist. All right? Sine theta equal to 1. We're dealing with a special case up here. So what do we got? We got what? Pi over 2, and we only have 1. We're done. Because down below, instead of positive 1, what would it be? Negative 1. Cosine theta, 1/2. That means we're talking about what family? Pi over 3. Cosine's positive in the first quadrant, pi over 3. Cosine's positive in the fourth quadrant, double 3, you get 6. 6 minus 1 is 5. And then number 7, another fishy one. Are we used to seeing root 3 over 2? Absolutely, but root 3 over 2 is usually designed for what two trig functions? Sine and cosine, right? Sine, you would have the pi over 3 family. Cosine, you got the pi over 6 family. is never associated with secant. Therefore, ladies and gentlemen, guess what? It does not exist. All right? If you're asking yourself, I'm a little worried about that one, put it in the calculator. Root 3 is 1.7, 2 is 2. 1.7 divided by 2 is 0.85, and secant and cosecant both have to be greater than 1. Good? Fantastic. Okay, let's shut down that video.